Microsoft has unveiled the Majorana-1 chip, a breakthrough that could transform the way we think about computing and the universe itself. Imagine a world where computers can solve problems in seconds that would take today's fastest supercomputers thousands of years. A world where quantum computing is not a distant dream, but a reality. Today, we're witnessing a major leap towards that future. It's a chip that promises to redefine the very fabric of computational power. So, let's go on to the details to see why exactly this chip is so groundbreaking. To understand Majorana-1, we first need to look at the groundbreaking physics behind it. At its core, this chip is built on an exotic type of quasi-particle known as a Majorana fermion, an entity that is its own antiparticle. These particles exhibit unique quantum properties that make them ideal for constructing what's known as topological qubits. Unlike traditional qubits that rely on fragile states, topological qubits take advantage of the exotic properties of Majorana fermions. These particles, which are their own antiparticles, offer the potential to build more stable and robust quantum systems. But how did we get here? And what does this mean for the future of technology? For years, quantum computing has been a vague goal. Qubits, the fundamental units of quantum computers, are notoriously fragile, easily disturbed by even the faintest noise. This has made it difficult to scale quantum systems and achieve real-world applications. Then came topological qubits. Unlike their traditional counterparts, topological qubits are far less susceptible to noise, making them ideal for large-scale, error-resistant quantum computers. Microsoft's Majorana-1 chip is one of the first successful demonstrations of this groundbreaking technology. The magic behind the Majorana-1 chip lies in the braiding of Majorana fermions, particles that don't just exist in isolation, but instead are intertwined in complex patterns. This process, known as topological quantum computing, helps encode information in a way that is naturally resistant to errors. By manipulating these particles, researchers at Microsoft are laying the foundation for a new era of computing, one that is more stable, efficient, and scalable than anything we've seen before. Microsoft's strategy is simple. Focus on the stability and scalability of quantum systems. Traditional quantum computing faces a significant barrier: quantum error correction. For quantum computers to be useful, they need to remain stable over time, allowing for complex computations to take place. But until now, qubits have struggled with maintaining their integrity. Topological qubits, however, are fundamentally different. Their resilience to errors makes them ideal candidates for quantum systems that can scale up, potentially paving the way for true quantum supercomputers. What does this mean for the future? Imagine a world where complex molecules can be simulated to develop new drugs, or where quantum computers crack problems so complicated they would be impossible for classical systems. The implications for fields like cryptography, materials science, and artificial intelligence are staggering. The Majorana-1 chip brings us one step closer to making these breakthroughs a reality, transforming industries and solving problems that were once thought unsolvable. But the road ahead is not without challenges. While the Majorana-1 chip represents an incredible leap, there's still much work to be done. Topological qubits are a promising foundation, but further research is needed to refine and scale this technology. The journey toward practical quantum computing will require overcoming technical hurdles, from improving the stability of Majorana fermions to scaling the chip's architecture for larger systems. The Majorana-1 chip is not just a scientific breakthrough, it's a new chapter in the history of computing. It represents the convergence of theory, technology, and ambition. As we stand on the precipice of a quantum revolution, one thing is clear: the future of computing is quantum, and Microsoft is helping lead the way. But what do you think? Is Microsoft's approach the right one, or will competitors like Google and IBM maintain the lead? Let us know in the comments below, and if you enjoyed this breakdown, don't forget to like, subscribe, and hit the notification bell for more insights on AI and quantum computing.